This video will cover the third page of notes on the topic of solving log equations. In the previous page, we solved exponential equations by using logs. Now we're going to solve equations that have log in them. So we are solving log equations. For example number 3, we're asked to solve the log of base 2 of 0.1. One thing I want to make sure that you notice is that it doesn't tell me what I need to solve for. So this one might have the words evaluate. But you would do the same thing for evaluating this expression as well as if you had to solve when it was equal to x. Just like we did changing exponential equations into logs, let's use exponents. In other words, let's change this into an exponential expression. We know that we have the base of 2 with the exponent of x, and it will equal to 0.1. So we can see that right here. From here, we would try to get the same base. Since we cannot get the same base, let's take the log of both sides. I know you're saying, wait a minute, we started with logs and now we went to exponentials and now we're going back to logs. You'll see why in just a second. So I'm going to take the common log to both sides. I'm going to use the third property of logs by putting the exponent to the front. So now I have x times the log of 2 is equal to the log of 0.1. And then from here, I'm going to divide both sides by the log of 2. And then we get my expression that x is equal to the log of 0.1 divided by the log of 2. And I showed you here what you would input into the calculator so that you can figure that out. Remember, we could have also used a natural log. Let's try another example. If we have the log of base 5 of 23 and we want to evaluate that expression, set it equal to x. We're going to change this into an exponential form. So I'm going to have the base of 5. I'm going to have an exponent of x, and it's to equal to 23. And that's what we see here. Now I'm going to take the natural log of both sides. So I have the natural log of 5 to the x is equal to the natural log of 23. Using the third property of logs, I'm going to bring my exponent to the front. So now I have x times the natural log of 5 is equal to the natural log of 23. Divide both sides by the log of 5. And you can see what I get here for x. Now I'm going to go on ahead and mention it here that you might see this when you ask for help in the homework as the change of base formula. And what it says is that if you have the log of some base, of some number, so we'll call it m, and you want to change the base into something that you know, then you can rewrite this as the log of some other base of m divided by the log of that other base of b. So that's essentially what we did. We changed it from the log base 5 to the natural log. The natural log of 23 divided by the natural log of 5. Similarly, we did the same thing up here where we had the base 2 and we wanted to change the base 2 to base 10. So I have the log of base 10 of 0.1 divided by the log of base 10 of 2. Remember, log of base 10 and common log are the same thing. And for my last example, we have an exponential equation, which we learned that if we cannot get the same base, then we need to take the log of both sides. Again, I'm going to use common logs. I'm going to take the log on the left and the log on the right. So I have the log of 7 of the exponent x plus 3 is equal to the log of 2. I'm going to use the third property of logs by putting my exponent to the front. Notice that I put a parenthesis around that exponent. So now I have our exponent of x plus 3 times the log of 7 is equal to the log of 2. I'm going to divide both sides by the log of 7, and I find that x plus 3 is equal to the log of 2 divided by the log of 7. So remember, we're solving for x, so I'm going to subtract 3 to both sides, and that's how we get our last answer that we have down here. Again, I want to remind you that this is the one we want to keep. This is what we have as an exact value. If you were in my math lab, maybe they want an approximation, but on the test I will be always asking for the exact value. And that concludes this video.